Once you know how to read an absolute value inequality, the process of solving becomes quite simple. So let's go ahead and read this absolute value inequality. This means that 2 times the distance of the variable from the number 2 must be less than or equal to 5. 2 times the distance of the variable x from the number 2 must be less than or equal to 5. Now, to solve this inequality, the first thing that we have to do is we have to divide both sides of the inequality by the number 2. When we divide both sides of the inequality by the number 2, this becomes a 1, and this becomes a decimal value or a fraction value. The decimal is 2.5. So now we get an absolute value which says the distance of x from the number 2 must be less than or equal to 2.5. Now, we break up this absolute value inequality by dropping the absolute value and creating 2 inequalities out of that. We get x minus 2 is less than or equal to 2.5, which is exactly like the original. It just doesn't have the absolute values. And x minus 2 is greater than or equal to negative 2.5. So remember to switch the sign, the inequality, and change the sign. Solving for x on both sides, we're going to get the following solution. X is less than or equal to 4.5. That's by adding 2 on both sides. And x is greater than or equal to negative 0.5. That's also by adding 2.5. Now, because this inequality is a less than or equal to and a greater than or equal to, this means that the endpoints are indeed solutions. So we can fill these dots in. They don't have to be hollow. So we fill these dots in. So that means that negative 0.5 and 4.5 are solutions to the inequality. Let's move 4.5 into position, and let's move negative 0.5 here into position. And so there we go. We have solved the inequality. As the problems become more complex with the absolute value, we're really going to solve them the same way we've been solving them, but to look at them and tell what the center is, to tell what the distance is from that point, it gets harder and harder to tell. So what we do is we practice so that we can learn the process. And so we're going to follow the same process here that we've done in all the other videos. Now, I could tell you that this right here represents the distance of x from 5/3 has to be greater than 7/3, but there's just no way that's going to make sense right now. So really what we need to do is just go through the process. So here's the first thing that we do. We split the inequality up into 2 inequalities when we drop the absolute value. So we get 3x minus 5 is greater than 7, which is exactly the same as this. It just doesn't have the absolute values. Or 3x minus 5 is less than negative 7. So we switch the inequality's direction and we change the sign. Then I add 5 to both sides of these inequalities. When I do that, I get 3x is greater than 12, or 3x is less than negative 2. The last thing to do is to divide both sides by 3. When we do that together, we're going to get x is greater than 4, or x is less than negative 2/3. So up here in red, the solutions are all in red. These are the values of x that are greater than 4. These are the values of x that are less than negative 2/3. I don't have the point graphed, but the center point here is 5/3. and the distance from 5/3 is going to be 7/3. But we don't care. We've got the solutions. And so once we practice enough with our algebraic solutions, once you know how to split up an inequality into several inequalities, that is an absolute value into several inequalities, then even though it gets more complex to see what the distance is, we can still solve the problem.